In this video, we will explain how to show whether a function is injective or not, and how to show whether it is surjective or not. And of course, if we can decide those two, then we can decide whether it is bijective as well. So let's start with injective, and let's suppose that we are given a function f from a to b, and we are asked to show that it is injective. So in general, the way we proceed is as follows. We take two elements a1 and a2 of a. We assume that f of a1 is equal to f of a2, and we must show that a1 is equal to a2. Again, to show that f is injective, we take two elements of a1 and a2. We assume that f of a1 is equal to f of a2, and we try to show that a1 is equal to a2. For example, suppose we are asked to show that the function f from the integers to the integers defined by f of n is equal to 5n minus 3 is injective. So the first part, we start with taking two elements of the integers. Let's label them m and n. Then we assume that f of m is equal to f of n. And what we must do, we must show that m is equal to n. And this is just algebra now. We assume that 5m minus 3 is equal to 5n minus 3, so 5m is equal to 5n, so indeed m is equal to n. And therefore, we have shown that f is injective. So let's now move to the task of showing that a given function is not injective. Let's suppose that we are given a function f from a set A to a set B, and we are asked to show that f is not injective. Then what we need to do is to find two elements a1 and a2 of a, which are different. a1 is different from a2, but for which f of a1 is equal to f of a2. For example, suppose we are asked to show that the function f from the reals to the reals defined by f of x is equal to x squared plus 3x plus 2 is not injective. So to do that, we need to find two elements of the real numbers which are different, but for which f applied to them gives the same answer. And okay, so in my answer I will cheat a little and I say that I observe that f of 0 is equal to 2. Yes, 0 squared plus 3 times 0 plus 2 is equal to 2. I observe that f of minus 3 is equal to 2 because minus 3 squared is 9 plus 3 times minus 3, that's minus 9 plus 2 is indeed 2. So yes, f of 0 is equal to f of minus 3 is equal to 2. So f is not injective. And I'm done. I don't need to write anything else. But however, one question arises. How did I find this 0 and minus 3? In fact, there is another question. What can we do in general if we are asked to decide whether the function is injective, but we are not told to show that it is injective or to show that it is not injective? And actually, both questions have sort of the same answer. We just start with the function f. We take two elements from the domain, x and y, and we assume that f of x is equal to f of y. And then we proceed with our algebra. And if we can show that x is equal to y, then we get that f is injective. If we cannot show that, then maybe we get some other relation concerning x and y. Now, if this relation gives us a pair with x different from y, but for which still we have f of x is equal to f of y, then f is not injective. So in general, what we do is the following. We start with f of x being equal to f of y, and we either try to show that x is equal to y, and deduce that it is injective, or try to find a pair for which x is different from y and deduce that f is not injective. So in the particular example that we had, where f of x was x squared plus 3x plus 2, if we assume that f of x is equal to f of y, i.e. x squared plus 3x plus 2 is equal to y squared plus 3y plus 2, I bring both to the left hand side, is equal to 0, I do some factorizations, I end up with x minus y times x plus y plus 3 is 0, and so either x is equal to y or x plus y is equal to minus 3. So here, I didn't deduce that x is equal to y. Either x is equal to y or x plus y is minus 3. And this relation, x plus y equals to minus 3, gave me this choice x equals 0 and y equals to minus 3 that I've written earlier, which was showing that f was not injective. Alright, so let us now move to surjective functions. So suppose we are asked to show that a function f from a set A to a set B is surjective. So what we need to do is the following. We must, for every element B in B, find an element A in A for which f of A is equal to B. For example, suppose we are asked to show that the function f from the reals to the reals defined by f of x is equal to 2x minus 7 is surjective. Then what we do is the following. We start with an element y in R. This y is taken to belong in the codomain. Here, of course, the domain and the codomain are the same, but we think of y as belonging to the codomain. And we need to find an x for which f of x is equal to y. And I claim that x equals y plus 7 over 2 works. And yes, it does, because f of x is twice this x is twice y plus 7 over 2 minus 7, which is y plus 7 minus 7, which is indeed y. So I have shown that f is injective. Okay, so how did I found x equals to y plus 7 over 2? Well, what I do, I solve the... Okay, so this x equals y plus 7 over 2 doesn't come out of nowhere. What we do is we solve the equation f of x equals y. And here solving f of x equals y, 2x minus 7 equals y, indeed gives x equals y plus 7 over 2. Sometimes I may have more choices for x, but what matters is that we must have at least one choice. If we have one for every y, at least one choice of x, this is enough. And what about to show that f is not surjective? Suppose we are given a function f from a set A to a set B, and we are asked to show that it's not surjective. Then what we need to do is to find an element of the codomain, an element B in B, for which there is no element of the domain, let's say A in A, with f of A equals to B. So as an example, suppose we have a function from the reals to the reals, defined by f of x equals x squared plus 6 plus 3, and we are asked to show that it is not surjective. Okay, I do some algebraic manipulations. I write f of x as x plus 3 squared. I complete the square, and I need to have minus 6 because 3 squared is 9, and I need to subtract the 6 to get the 3. Okay, but I now observe that this f of x written as like this, it's surely greater or equal to minus 6. Okay, so if I take b to be minus 7, then I see that there is no real number x for which f of x is equal to minus 7, because all answers are greater or equal to minus 6. And so f is not surjective. I have found the element of the codomain, the element, let's say, y of the codomain, for which f of x is not equal to y. And in general, if we are asked to decide whether f is surjective or not, we investigate the equation f of a equals b for every element b of b. If for every b in b we have at least one solution, then f is surjective. If even for one b in b there is no solution, then f is not surjective. So in the previous example, we will have to investigate the equation f of x equals to y. F of x was equal to x squared plus 6x plus 3, so we investigate the equation x squared plus 6x plus 3 is equal to y. And we can solve the quadratic, and after some algebraic manipulations, we get that x is equal to minus 3 plus or minus square root of 6 plus y. Remember, we don't mind if we have more than one solution. What we mind is that we have at least one solution. But actually here we don't always have a solution. We only have solutions when y plus 6 is greater or equal to 0. So f is not surjective. taking y equals minus 7 as we did before, there is no solution. Okay, another thing to keep in mind is that in these exercises, they depend very much on the domain and condomain. For example, if my condomain, instead of being the whole set of real numbers, was the set from minus 6 to plus infinity, then the function defined by the same formula will be surjective. And this is shown by our previous calculation. If you give me a y between minus 6 and infinity, then by taking x equal to minus 3, let's say plus square root of 6 plus y, I get that f of x is equal to y. I already solved this equation before. So this new function f is surjective. The previous one isn't. The only difference is the codomain.